Okay, so in this problem we want to ultimately take the limit as n is going to infinity. First thing I can do is, this guy being all in terms of n is constant as far as the sum is concerned, and so we can pull that out of the sum. We pull that out of the sum, and then to simplify the expression in the sum, I'm going to take this guy and just multiply it out using the FOIL method. And if we do that, I squared minus 2i plus 1. Right, then we can apply the sum to each one of those terms. So it would be the sum, so let's see, all of this times the sum as I goes from 1 to n of I squared, minus the constant 2 can come out of the sum, so just the sum of I, and then we've got the sum of just 1. Right now we've got a special formula where we can get this sum in terms of n and this sum in terms of n, and then we know that if we add 1 n times, that just gives us n, so we can get each of those sums in terms of n. So this first one is n times n plus 1, it's 2n plus 1 all over 6. And then I've got minus 2 times the n times n plus 1 over 2. And then if I sum 1 n times, I get just n. So of course these guys will cancel. Right, and then last thing that I think I can do to help me evaluate the limit is I can distribute the 1 over n cubed through. So limit all of, I'm just going to write this as 1 over n cubed. And I'm not going to worry about multiplying all of this out. We could, but I don't think I need to. So let's see, minus 1 over n cubed times n plus 1 over 2, and then finally if I do 1 over n cubed times n, that would be 1 over n squared. Right, so now if I look at this first term, I've got an third degree over a third degree. So in order to evaluate that limit as n goes to infinity, I just need to take leading coefficient over leading coefficient, and I also have to include this 2 because that would get multiplied into the leading coefficient if I did take the time to multiply all this out, which I'm not going to. So that would be 2/6. Now this guy, oh I'm sorry, this should be right here, I messed up, this should be n cubed. Now this term is a second degree over a third degree. Remember, when you take the limit as n goes to infinity of a rational expression where the degree of the denominator is larger, that limit is just going to go to 0. Because the denominator is going to increase faster, and so same thing here when there is no n in the numerator, so this guy is going to be 1 over some number that's getting larger and larger and larger, so that's going to go to 0. And so your limit is 1/3.